Hello everyone. My name is Muhammad Abdul Rahman. Today we are discussing about the Ministry Past Paper, which is session 2024. Today we are discussing just the multiple choice question, and inshallah tomorrow we will further continue with these questions. Okay. Before wasting your time, we have to start our session. All right. So the first multiple choice question is. The energy transfer per unit charge is the definition of what? All right. So this is the first question that the energy transfer per unit charge. So we already know about it that the potential difference is actually equal to energy per unit charge. So this is the simple definition, or you can also say that work done per unit charge is also the definition of electric potential. So the right answer is potential difference. If I'm talking about the power, so the definition of power is the product of current and voltage. So this is the definition of power. So P is equal to IV is the actual definition of or mathematical form of power. If I'm talking about the current, so the definition of current is I is equal to charge per unit time. This is the equation. The charge per unit time is the equation of current. So it's not here. About the, if we're talking about the drift velocity, so we know that the equation of drift velocity is uh, I is equal to N Q V A. And V here is equal to I divided by N V, N Q A. Here I is the current and is the number of electron per unit volume. Q is the charge and A is the area. So the answer of this question is potential difference. Okay. Okay, the second one is the SI unit of charge. So the charge is a system international unit. So basic unit of charge is obviously coulomb. So the right answer here is coulomb, not voltage, not joule, not ohm. So the right answer is coulomb. So this is the right answer of this question. Okay. So now we have to move apart. This is one of the difficult question. Question number three. Now focus on this question number three, and we have to solve this complicated circuit. All right. So the question is, what is the total resistance of this circuit? So we have to find the total resistance of this circuit. So how we can find out the total resistance? All right. So you see that in this circuit, we have a resistance R, and the second resistance is also R. So I just call down this R1, R2, R3, and R4. So we have four resistance, R1, R2, R3, and R4. Okay. The first important thing, whenever you solve this type of question, the first important thing you have to understand about the node. I mean, which one is series and which one is parallel. To find out this, we have to know about the node. So we see that we have two nodes here. All right. This is, we call it node 1. This is, we call it node 2. All right. Now remember one thing. So when the current is passes through here, so we see that when they reach at node 1, so they are divided into two parts. Half of the current, some of the current will passes through R1 and R2, and some of the current is passes through R1, R3, and R4. Now look at this very deeply. We see that R1 and R2, here you see that the current is moving in one direction. So there is no node between R1 and R2. So you can see that here R1 and R2 are connected in series. All right. Similarly, if I'm looking for R3 and R4, we see that the current is moving from node 2 and they are moving in one direction. So we see that R3 and R4 also connected in series. All right. So this is a combination. But if we look that R1, R2, and R3 and R4, but both were connected in parallel because we see that the current is now divided. So how we can find out the equivalent resistance? The first important thing, we have to find out R1 and R2. So total resistance of R12 is R1 plus R2, which is equal to R plus R, which is equal to 2 times R. Now, if we're talking about R3 and R4, so what is the total resistance? So R34 is equal to R3 plus R4, which is equal to R plus R, which is also equal to 2 times R. Now, you can see that here R2, R12 and R34 were connected in parallel. So how we can find out the total resistance? For parallel combination, we already know about it. So R total is equal to 1 divided by R12 plus 1 divided by R34. So the answer is now 1 by R12 is actually equals to 2 times R, and 1 by R23 is also equal to 2 times R. So total resistance, so R total is equal to, here 1 by 2 is common and also this one is common. So actually we are writing out this 1 over R is common. So here 1 by 2 plus 1 by 2. So 1 by 2 plus 1 by 2 is actually 1. So which is also equal to 1. So our total resistance is R. So this is our right answer. So our right answer is R. Okay. So this is the method that you can find out the total resistance that any type of circuit which is given. So you have to find out the total resistance like this. Okay. Now we have to move apart. All right. Okay. Question number 4. Now we're discussing about the question number 4, and we have to know that how to solve the question number 4. Okay. So remove these things. So okay. Okay. Yes. So now we move towards the question number 4. And our question number 4 is the figure opposite show an electric circuit. If the internal resistance is R equal to 1 R by 4, what is the VR? Okay. So he's talking about what is the value of VR. Remember one thing, whenever you solve the each and every type of numerical, so you have to first look at the diagram, what they are talking about. The second thing, you have to understand the concept. And the second and third thing is you memorize the formulas which is used in this circuit diagram. All right. So if we look at this particular question, they are talking about the internal resistance. All right, and external resistance. And we have already know the formula of this, that EMF is equal to I into small r plus I into big R. If you don't remember this formula, so just you can also use the Kirchhoff law to find out the actual formula of this question. Okay, if we're using Kirchhoff law, so we can see that this is my loop. I just write down this A, B, C, and D, and we can make this formula. Here, this 20 volt is actually my EMF. Here, the current drop across it is voltage drop across it is I into small r, and that one is I into big R. So if we're moving from point A to B to C to D, so our loop is actually, the first one is they are moving from negative towards positive. So just write down this positive E times. Then we have a current drop across I into small r. Just write down this I into small r. And then we are moving from the big R. So just write down this I into big R. By using Kirchhoff law, we can also find out this type of question. And if we rearrange this thing, equation, then you can write down this E is equal to I into small r plus I into big R. Now just look at the condition. He said that if the internal resistance is R divided by 4, how we can solve this thing here? Also, he showed that the value of EMF is 20 volt. Now just put the value, you can get the answer. Here EMF is 20 volts, so just write down this 20 volt is equal to, here I don't know about the value, but the value of small r is actually r divided by 4 plus the value of big R is I into R. If you solve this particular thing, so we see that our answer is 20 volt is equal to, here IR is common, so we just put the IR outside, and inside it we have 1 by 4 plus 1. So if you further solve this thing, so 20 is equal to I into R. And that is, if we take the LCM of 1 by 4 plus 1, so it will be equal to 5 divided by 4. Okay. Just to solve this thing, so IR is equal to 20 multiplied by 4 divided by 5. So 5 ones are 5, 5 fours are 20. So IR is equal to 16. So our answer here is 16. All right. So this is the method that you can find out the answer below here. All right. So this is the simplest method. Now we have to move the numerical number 5. Sorry, multiple choice question number 5. And question is here is move apart. Okay. Move, like this. Okay, just try just to remove this thing. It will take some little time. I hope so you can understand this. Now, question number 5. Oh, sorry, that one. All right. So, what is the magnitude of current in the diagram show below? So, look at this question. They are talking about the Kirchhoff first law. So, we say that Kirchhoff current law. Okay. So, and the Kirchhoff current law is actually sum of current enter is equal to sum of current leaves. Okay. So this is the definition of Kirchhoff law. Maybe they were asking about a definition, so you have to know about it. And we also know that the Kirchhoff current law is actually obey the conservation of charge. Okay. So conservation of charge. So Kirchhoff law is actually obey the conservation of charge. Okay. Now look at this diagram very deeply. We see that here the current I2, this is we node. First of all, we have to take the nodes. We have this is one node and this is the second node. Okay. We see that here current 2 ampere enter into the node. Similarly, 5 ampere is also enter inside the node. But if I'm looking for this 1 ampere, it's leave out from this node. And if I move from this node 2, we see that 3 ampere is also leave. Here current I is also leave and 2 ampere is also leave. All right. So just rearrange these things and you can get the answer. Okay. So how you can get the answer? The first thing is current enter is equal to current leave. What is the value of current enter here? So we see that here 2 ampere is enter. So for enter 2 ampere plus, and the second one is 5 ampere. And this is my 5 ampere, which is current enter. And the second one is current leave. So the current leave here is 3 ampere. So just write down this 3 ampere plus current leave is I. So just write down this I plus current leave is also 2 ampere. Just write down this 2 ampere and current leave is also 1. So just write down this. Okay. So just to rearrange the value, you can get the answer. So 5 plus 2 is actually 7 ampere is equal to from on the right hand side. So 3 plus 2, 5 and plus 1, 6. So 6 ampere plus I. So what is the value of I? So I is equal to 7 ampere minus 6 ampere. So I is equal to 1 ampere. So the right answer here is 1 ampere. This is the method that you can find the current across here. Okay. Now we have to move apart. and move to the question number 6. And let's see how we can solve the question number 6. Okay, just remove just 2-3 minutes. So apart from here, and let's move towards the question number 6. Okay. Now let's move. So our question number 6 is also a very simplest one, not a difficult one. So first of all, you have to read the question. What is the resistance? So they are talking about the resistance. So what is the resistance of the copper wire whose resistivity is 1.72 into 10 power minus 8 ohm meter? So remember one thing, resistivity is given and they are talking about the resistance. And one thing you have to see that here the length is also given, which is 0.5 meter. And also he gave the radius, which is 5 multiplied by 10 power minus 4. So in this method, you can find the resistivity of this circuit. Okay. So how we can solve out this thing, right? So how we can solve this circuit? So we know the formula that R is equal to rho L divided by A. Okay. We just put the values and you can get the answer. Okay. So the answer is R is equal to, what is the value of rho? So 1.72 into 10 power minus 8. And what is the value of length? And the value of length is 0.5. And the value of area, we know that the formula of area of the sphere is pi r square. Just put the value, you can get the answer. So here pi is 3.14 and radius. So what is the value of radius? 5 multiplied by 10 power minus 4. Just put the value, 5 multiplied by 10 power minus 4 square. So now you have to solve further and you can get the answer. So R is equal to 1.72 multiplied by 0.5 divided by 3.14 multiplied by 5 square is 25, and the upside is 10 power minus 8 and the lower side is 4 square is 10 power minus 8. Just cancel this thing and you will get the value of resistance, which is equal to 1.1 into 10 power minus 2. So this is my right answer of this question. Okay. So this is the method that you can solve the question related with this topic. All right. So this is today we discuss only the 6 MCQs. So now, inshallah, the next lesson we will discuss the rest of the numerical problem related with this. All right. Thank you very much.